squared plus 6x minus 7, something like that. Our goal in this section is to take an equation that looks like that and put it in vertex form. Vertex form is y equals, now it could say y or it could say f of x, instead of standard form, which is ax squared plus bx plus c, it looks like this. Y equals a times, you have a binomial squared, x plus or minus some number, parentheses squared, and then plus or minus a constant. Okay? That's vertex form. Our goal is to take any type of quadratic equation, which that just means the highest power is 2, and look at it and manipulate it to be able to tell what the vertex is. Okay? Well, what's the vertex? Well, if you have a quadratic, it's going to form a parabola on the graph. The vertex is either the highest or the lowest point. So, if your parabola opens up, it's a U shape that opens up, then this point down here is the vertex. It's the lowest point. It's also called a minimum, right? If your parabola opens down, then your vertex is the highest point, and what's it called? A maximum. Good. So the problems in your homework are going to ask you to look at this problem and tell me what the vertex is. Okay? Sometimes, if the problem's already in vertex form, that's very simple to do. Okay? H and K represent your x value and your x coordinate and your y coordinate for your vertex. When you're looking at the problem in vertex form, the number with the x is your x coordinate. If it's in parentheses, then it is automatically the opposite sign. Okay? So in this first problem right here, what's the x coordinate for the vertex? 3. It's a positive 3. And what's the y coordinate? 7. It's the number out here. It's the constant that's added or subtracted to your binomial square. Okay? So, and that number is outside of the parentheses, so you take it sign for whatever it is, okay? So that's a positive 7. So that means my vertex is the point 3, 7. Now, in this section, you're not going to be graphing these, but like I said, in Math 3, we want you to start relating the equation to the graph. So, my vertex is 3, 7. So, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it's right here. Now, there's something in this form that tells me whether the parabola opens up or down. Anybody know what that is? Kind of. What were you going to say?
Negative or positive.
Negative. What is negative or positive? A. If A is positive, it opens up. If A is negative, it opens down. Okay? Now, later on, we're also going to start dealing with some that open left and right. Okay? Not today, but that's coming. But it's the same concept. If A is positive, it opens to the right. If A is negative, it opens to the left. But today we're just talking about up or down. So in this first problem, what number is A? What is A? 1. If you don't see anything, there can always be a 1 multiplied to something. So that's how we know that A is positive, and we know it opens up. So if I had to draw a rough sketch of that parabola, it would look something like that. So if all we know is the vertex and it opens up, that's what we would look at. Okay? Over here, what's the x-coordinate from our vertex? Negative 4, and my y-coordinate? Negative 1. So negative 4, negative 1. So 1, 2, 3, 4, and negative 1, which is down here. Does it open up or down? Up. Because what is A? It's positive 1, right? So we know it opens up. Okay, I don't know anything else about where it crosses, but I just know it opens up. Okay? But down here, what's the x-coordinate from our vertex? Negative 6, because we look right here. It's the opposite sign. So negative 6, and what's my y-coordinate?
4.
Positive 4. So negative 6, it's negative 1, 2, 3, 4, 5, 6, and positive 4. Does it open up or down?
Down.
Down, because A is negative 1. So it opens down. Okay, so it does this. Now, if I asked you, this is my vertex point. Is it a maximum or a minimum? It's a minimum. It's the lowest point on that graph. It's a minimum, right? What about this one?
Minimum.
And what about that one?
Maximum.
Maximum, good. Now, without you knowing what the solutions are, how many real solutions does this graph have? None. Why? It doesn't touch the x-axis. It doesn't cross the x-axis. So this first one has no real solutions. It's still got solutions, but they're going to be imaginary. What about this one? Two real solutions, right? And what about this one? Two real solutions. Because both of those other ones cross the x-axis in two places. Okay? Okay. Like I said, the problems in your homework are going to ask you, tell me what the vertex is. Okay? Our goal, now you don't need to write this down here, but this will be our goal. It'll say, write the quadratic function, here's an example of one, in vertex form. What is the vertex of the graph? And find the solution. Well, the only way to go from this form to vertex form is to complete the square. Now, those of you that came from Math 2, we did completing the square in Math 2. Okay? So this should be a review. If you came from another school, then just pay close attention. It's not difficult to do. It's just something you haven't done before. Now, all it is mathematical manipulation. Okay? Okay, so you'll be given y equals something x squared plus or minus something x plus or minus a constant. First of all, before you even begin this process, it has to be y equals, meaning y by itself. Okay? So if they take something that's like 3 plus y, you have to get that y by itself first before you can even begin anything else. So you want to take anything else that they throw over there with the y and put it on the other side and put it in the right order. Okay? So that's step one. You can't even begin to do anything until it's y equals. All your homework problems are already y equals. Okay? So you don't have to worry about that. Now, what we're going to do is you're going to take your constant, which is your term without a variable, and you're going to get rid of it. You're going to put it on the other side. You're going to move it on the other side. You're going to put it over there with the y, because what we're going to try to do is we're going to create what's called a perfect square trinomial. If you have a perfect square trinomial, then you can factor it to where it's a binomial times itself, and then you can write it as that binomial squared. That's your goal, okay? All we're going to be doing is manipulating it. So first, take your constant, move it out the way. After you do that, you want to make sure that the number in front of x squared is a 1. You don't want anything to be in front of x squared. So if it's a 2x squared, then you're going to have to factor out a 2. Okay? Now, all your homework problems, there's nothing in front of x squared. Okay? This is just to get you to refresh your memory. They're not super complicated problems. But you have to have the coefficient of x squared be 1, positive 1. After those conditions are met, then we're going to force it to be a perfect square trinomial. We're going to force it to be a perfect square trinomial. And what we do is, so you'll just end up with stuff on the left, and then you'll have something x squared plus or minus something x. Those are the only two terms you'll have at that point. You'll take b, which is the number that's multiplied to x. You'll divide it by 2 and then square it. That will be your new c that will force you to have a perfect square trinomial. But since it's an equation which you add to one side, you also have to add to the other. Okay? After you do that, Then you'll have your perfect square trinomial. You'll factor it. That'll give you your binomial square, which will look like this. It'll look like this. And the last thing you'll have to do, since you moved that constant out of the way in the very beginning, it's with y now. The last thing you'll have to do is you'll have to put it back, because that'll be your k term. That's your y coordinate for your vertex. Okay? It sounds like a lot, but once you do it a couple times, it's really not. Okay? And it's the only way to go from standard form to vertex form. In Math 2, you may have learned completing the square to solve an equation. You're not going to do that. I would never use that method to solve an equation. Okay? I would only use completing the square for this. Okay, before we actually start rearranging stuff, let's refresh our memory on how to force something to be a perfect square trinomial. Okay, so you should write this down. Okay, so we're going to make this be a perfect square trinomial by taking your b term. So we're going to create a new c term. This is where c would go, right? ax squared plus bx plus c. Right? Everybody see that? This is what we don't know. C is what we don't know. That's going to go there. All right? In your homework, it'll have this, and it'll say find c so that it creates a perfect square trinomial. Then write the binomial square. Okay, trinomial means how many terms? Binomial means how many terms? 2. So it sounds like a lot of terminology, but that's how the directions read. So find c just means, what do you have to put here that makes this a perfect square trinomial so that I end up with this, okay, a binomial. So what is b in that first problem? -12, right? So we said c is equal to b divided by 2, and then you square it. So c is equal to, now, do we need to put -12 divided by 2? Does it matter? No, why not? Because it's in parentheses, but what are we going to do to it after that? We're going to square it. It doesn't matter. Once you square something, it's always what? Positive. So don't worry about the sign of what b is. Just worry about the number, because it's irrelevant. The sign's irrelevant. So you say 12 divided by 2, and then we're going to square it. So 12 divided by 2 is 6, and you square it, and you get 36. So what goes right here is 36. Now we have forced that to be a perfect square trinomial. Well, what makes it a perfect square trinomial? Well, let's factor it. Now, you factor this using whatever method you learned. If you learned the AC method, or if you learned the T-chart, or I think there's an X one or something, and I taught guess and check. So, use whatever method you learned to factor a trinomial. Now, when I multiply my first terms, they have to equal this, right? So what do these have to be? X and X, right? When I multiply my last terms, they have to equal my last term. And we want them to be the same because we just made that happen. So what is that? Okay, so 6 and 6. This sign right here tells you what both of these have to be. This tells you they both have to be negative. Okay? We know that's right because if I redistribute everything, I'm going to get that trinomial back. If I FOIL it, I'm going to get that trinomial back. Okay? That's your goal. We made this happen so that this could happen. Now what goes in here? X minus 6. Anything times itself is that squared, right? Everybody see that? Okay, let's do the next one. So let's figure out what C is. What has to go here? So C is equal to, B is 20, right? 20 divided by 2, and then you have to square it. 20 divided by 2 is 10 squared is 100. So this has to be 100. So what's my first terms have to be? X and X. What's the last terms have to be? 10 and 10. What's my signs have to be? Both pluses. So what goes in here? X plus 10. Okay, so we started out with this, ended up with this. That's your goal. That's how we start out with this and end up with this. Y'all see that? That's how we start out with this and end up here. That's the process that causes that. Now, before we do this next one, notice the relationship between this number and this number. This number and this number. What is it? It's half. It's half of it, right? It's just that number divided by 2. It's b divided by 2. That'll happen every time. Okay? Let's do the next one. Now, how do we find c? We take b and do what? Divide it by 2, and then what? Square it. Well, you said it doesn't divide evenly. Well, that's okay. Just leave it as a fraction. And then you're going to square that fraction. When you square a fraction, you just square the top and square the bottom. That's it. So, same thing. C equals. B is 7, right? So we say 7. I'm not going to do anything different. Divided by 2 and square it. Just in this case, we're not going to calculate 7 divided by 2. Okay? So, if I square the top, what do I get? And square the bottom, what do I get? Okay, just leave it like that. 49 over 4. Alright. My first terms, again, are going to be x and x. What's my last term going to be? Just leave it as a fraction. Yes. 7 over 2. It's just going to be 7 over 2. Remember? It's this term divided by 2. That's it. Just leave it 7 over 2. And what do my signs have to be? They both have to be negative. Now, am I going to mark it wrong if you put 3.5? No. I'm not going to mark it wrong if you put 3.5. If you divide it by 2 and then square it, I'm not going to mark it wrong. Okay? I think it'll be 12.25 or...
Yes.
Okay. So that's fine if you put that. That's equivalent to 49 over 4. I can't mark that wrong. Okay? So if you're more comfortable with that, that's fine. Just know that whatever you put here is that b divided by 2. It's just before you square. Okay? Okay, so now that we know how to make our perfect square trinomial, let's go ahead and work a problem. Okay, so first we need to make sure that it's just y equals. Okay, and it is. In your homework problems, it just says y equals. Okay? So, step 1, take your constant and get rid of it. Move it to the other side. We do that because this is not a perfect square trinomial. I can't factor this and get something times itself. It doesn't factor that way. Okay? My first terms would be x and x. If I tried to factor this like this, my last terms, when I multiply them, they have to equal 4. And you might think, oh, okay, I can put 2 and 2. But then that doesn't check. X plus 2 times x plus 2 does not equal this. Okay? The way I check those, and I don't know if your teacher taught you how to check these, the quick way to check it is you multiply the inside and outside and combine them, and they have to equal the middle. Okay? So 2x and 2x gives you 4x. That doesn't check. So you can't factor that. That's not a perfect square trinomial. So we're going to force it to be. But before we can do that, we have to get rid of the c that doesn't work. Does that make sense? So we're going to take this one. We don't like that one. It doesn't satisfy what we need. Okay? And so move it over there, and what does it become? Minus 4. So we'll just do y minus 4 equals. Now we have this left. X squared plus 8x. I don't care what's over there with the y right now, because the very last thing I'm going to do, this is going to end up being whatever k is. The last thing I'm going to do is put it back where it goes. Okay? It's just over here for now, temporarily. Now we're going to force this to be a perfect square trinomial. So we need a new c. That works. Okay? But if we're going to add something over here, you have to add it over here too, because it's equal, because it's an equation. The left side has to equal the right side. So if you add something to this side, you have to add the exact same thing to the other side. So the next step, I say y minus 4 plus blank equals x squared plus 8x plus blank. Now we have to figure out what goes in that blank, and that's what we did on the slide before. Okay? So what's b? B is 8. Okay? So our the good c, the c that we want, is 8 divided by 2, and then squared. So that's 4 squared. That's 16, right? So I'm going to add 16 right here. Now that's going to factor into something times itself that's going to work. But if I add 16 over here, right now, I made that side really heavy. So I have to add 16 to the other side so that it stays balanced. Okay? So I just simplify this over here. Negative 4 plus 16 is what? 12. So y plus 12 equals. Now I'm going to factor that, just like we did in the slide before. What's my first terms have to be? X and x. What's my last terms have to be? 4 and 4. And what do the signs have to be? Both plus. And I know that works because I multiply 4x plus 4x equals 8x. So I know I did that right. Okay? So what do I do now? Not yet. I want this. So why did I do this? So I have to write it as a binomial squared. Okay? You don't want to leave it like this. That doesn't help you. That's not vertex form. So we have y plus 12 equals x plus 4 squared. You have to keep your goal in mind. We're trying to get it to vertex form so we can see the vertex. Everything has to be in its right place. Okay? Now we do what y'all just told me. What do I do? Move the 12 over. I can look at it right now and tell that my x-coordinate for my vertex is what? Negative 4. Okay? But k needs to be in the right place. So I have to take that 12 and put it over there. So y equals x plus 4 squared minus 12. Positive 12 over here. When I bring it to the other side, it's negative 12. Okay? So now I know that my vertex is negative 4, negative 12.
Why is 4 negative?
Part 2 of the problem says, name the vertex, and then it says, then solve. Wait a minute. On a graph, what are the solutions on a graph? Where it crosses the x-axis. Answer this question. If it crosses the x-axis here and here, what is that y value at those points? 0. The y value is 0. So if you're finding a solution, then y has to be 0. So solving is really not difficult at all. We already found this. In order to solve, all we have to do is let y equal 0 and then solve for x. So instead of y equals, we'll say 0 equals. X plus 4 squared minus 12. Well, we did these yesterday. This is what we did in section 5.3 and 5.4. So now what we do is get x by itself. What's the first thing I do? Add 12 to both sides, right? So just bring the 12 over, and it becomes positive 12. Trying to get x by itself. What do I get rid of next? The squared. How? Very good. Square root. This is why we reviewed how to do this. Okay? Simplify the square root of 12. 4 times 3, which is 2 square root of 3. So this is 2 square roots of 3. Don't forget the plus or minus, equals x plus 4. Trying to get x by itself, what do? Subtract 4, move the 4 over, right? If we take this plus 4 and move it over here, it becomes negative 4. These are my solutions. Those are where that graph crosses the x-axis. If I calculated that, if I did negative 4 plus 2 times the square root of 3, it would give me a decimal answer. Negative 4 minus 2 times the square root of 3 would give me another decimal answer. So that's the points where it crosses the x-axis. They're solutions.